Okay, so let's look at this one. It says there are 3 boys. Fix this to 2 5 girls in a class, so like a 3 to 5 ratio, right? 3 to 5. All right, and again, a strip diagram is super helpful here. So again, I might do 3, and I might just label boy, 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 and then draw a line to 5 girls here. 1, 2. So girl, girl, girl. Or you can make them up and down. So like, you know, boys and do 3 strips and girls underneath. Okay, so write the ratio of boys to girls 3 different ways. Okay, so I could go 3, 2, 5. I could go 3, 2, 5. I could go 3 fraction bar to 5. Okay. Joni says that there must be 8 kids in the class. Is this correct? Okay, and not necessarily. Because this is just the ratio. It might be reduced. So the ratio might be simplified. Okay, so for example, if every strip is worth, say, 3, right? So 3, 3, 3, 3, 3, 3, 3, 3, there could be 9 boys and what is that? 3 times 5, 15 girls. And that would still have the same ratio. Okay, so not necessarily the ratio might be simplified. There could be 9 boys to 15 girls, and that would still have that same ratio. If there are less than 40 children in the class, how many possible answers are the number of children in the class? Okay, so I'm going to use the 3. I'm going to write it this way this time. 3 to what? 5? Okay, so there could be, let's see, these are what? Boys, and these are girls. Okay, so there could be 3 boys and 5 girls. And then is everyone okay? I could scale it by 2. So again, I could double both, get twice as many. So there could be 6 boys and 10 girls. I could triple all of them. So make every strip worth 3, or triple this amount, 9 boys. And what is that? Times 3, 15 girls. All right. And then again, I could scale it by 4, 12 boys and 20 girls. I'm still under the limit here. And I could multiply that was by 4. How about by 5, 15 boys and 25 girls. Now it says there are less than 40 children. So if everyone is worth 5, so 5, 5, 5. So if every strip was worth 5, then I would have 15, 25. That adds up to 40. So I want less than 40. So there's 1, 2, 3, 4 possibilities. 4 possible solutions to that one. Okay, a person makes green paint by mixing 4 blue and, okay, so we have 4 parts blue and 2 parts yellow. All right, let's see. After mixing the paints together, so they're going to make green paint, so there's 18. How many gallons of each? Okay, so 18 divided by 1, 2, 3, 4, 5, 6 is 3, so every strip is worth 3. All right, and so how many gallons of each? So this would be what? 12 gallons of the blue, and what is that? 6 gallons of the yellow. And just double check, make sure it adds up to 18, and then again, make sure you have double this compared to that. Okay, if this person needs to make more of the same color and 2 quarts of blue, how much yellow would he or she need? Okay, so we have 4 parts of the one, and you could simplify that if you wanted to. I'm just going with what we're given, okay, because it's the same as 2 to 1. Is that okay? But I have 2 quarts of blue. So if I have 2 quarts of blue, that means each of these is worth a half, because I'd have to take 2 divided by 4, all right? And 2 divided by 4 is 2 times a fourth is 2/4, which is a half, a half, a half. So then these are worth a half each. Okay, so how much yellow would I need? It'd be 1 quart. And again, if you simplified this to 2 parts to 1 part, then if you had 2 quarts of blue, you know this is worth 1, this is worth 1. That would have to be worth 1. All right, let's go ahead and fill in the table. I'm going to start with 12 just because it's a whole number, kind of easy. So 12 divided by 6 to get down here. 12 divided by 6 is 2. I could also take half of it. Half of 6 is 3, so half of this is 12. Or half of 12 is 6, sorry. The other thing is I could go divide by 6, and then once I know what a unit is, I could double, triple, multiply by 8, multiply by 5, multiply by 6, and multiply by 7. And again, there's lots of places to double check yourself to make sure it's even and that you're doing it right. All right, here, again, getting your unit fractions huge. 4 batches use 2. So if I divide this by 4, right? So I want to divide by 4. This guy's going to get divided by 4. So 2 divided by 4 is a half, or 2/4. So then I know if I double a half, I get 1. And then this would be 1.5, 2, 2.5, 3, 3.5. All right. And then this one, if I'm dividing it by 3 to get one batch, I divide by 3. So this is going to be 1/3. So 2 of those will be 2/3. 3 of them would be 3/3. 4/3, 5/3, 6/3 is that, and then 7/3. And I don't care if those are mixed numbers or not. Okay, what if I need 1.5 batches? How many ingredients do I need? So 1.5 batches would kind of fall right between these two. So you might just reason like, oh, 3's in between there. Half a cup and 1 is what, 3/4 of a cup. And then here you might be like, I don't know what to do. You could get a common denominator of 6's. That might be easier to see. 2 6 and 4 6. You might be like, oh, 3 6's in the middle, which is a half. So you could just do it with logic. So you could say, what, 3 cups of flour is in the middle. Between a half and 1 is 3/4 of a cup of milk. And again, if you're like, I'm not sure on that, make this 2 6 and 4 6. And you guys can see that 3 6 of a cup of sugar is in there, which again is a half. So I should probably simplify that. If the numbers aren't pretty, then what you do is scale this up, right? By 1.5. So 1.5 is the same as 3/2. All right. So do you see how if I take 1.5 times 2, these cancel, I get my 3. And if I take 1.5, which again is 3/2, times this guy, I get my 3/4. And if I take 1.5, which again is 3/2, times that, I get the, let's see, what am I doing there? Oh, that was a third. No wonder it wasn't working out there. If 1.5 times 3, I get my half. So you could just scale it up by 1.5, times 1.5 to scale it up to something not there. All right, if I only have 1 3/4 cups of sugar and I have plenty of the other ingredients, how many batches could I make? Okay, so one batch calls for how much sugar? Okay, so I need 1/3 of a cup to make a batch. So I have 1 3/4 is what I have. And I'm dividing by what I need because I want to know, how many times it goes in there. And I know I have enough to make more than one batch. So how many batches can I make? So again, I might just do standard algorithm. 1 times 4 is 4, 5, 6, 7/4 divided by 1/3. And again, I am going to multiply by the reciprocal for the common algorithm. So I get 21/4, which is 5 1/4, let's see, batches, as long as I have everything else. Again, the other thing you could do here is get a common unit, because is everyone okay? This is measurement, they match. So I could literally do the measurement model. So times 3 times 3, 21/12 cups, and then scale by 4, and get 4/12 cups. So I'm measuring in 1/12 of a cup, which I don't know if they exist, but And so then you get 21 divided by, it takes 4 scoops to make a recipe. All right. And so then I can get my 5 1/4 that way. And I could draw a picture too. All right. Let's look at the top of the next page. Let's see. You need 300 milligrams of medicine every 8 hours. How much would you need per hour? So I could scale it down or up. So I could take half and get 150 in 4 hours. I could get 75 in 2 hours. So I'm just dividing by 2, dividing by 2, dividing by 2, dividing by 2. So then I could divide by 2 again, which is, what is that? Half of 70 is 35. So I'm breaking this in half. So half of 70 is 35. Half of 5 is 2.5. So that'd be 37.5 milligrams in 1 hour. The other thing you could do is maybe make a double number line. So 0, 0, and you could put your, what do we have? We have 300 milligrams in 8 hours. So I could kind of do the same idea. I could split it in half and do 150 in 4 hours. And then I could do in half again, 75 in 2 hours, and then I could split it in half again and get that, 37.5. So a double number line maybe would work, or scaling something. All right, I can make 5 scarves in 10 hours. Okay, so 5 scarves in 10 hours. So I have my scarves on top, my hours on bottom. So then over here, I would be able to make 7 scarves. So again, you want this to match. So scarves over hours, scarves over hours. And I'm going to cross multiply if you remember that. So 70 equals 5h. Divide by 5. H equals, what is that? 5 goes in there once. There's 40 left. Is that 18 hours? Okay. All right. So 5 goes into 7 once, 20 left over. How about 14 hours? Is that better? Let me double check. 5 goes in there once, and then there's 20 left. Okay, I'm liking my 14 hours better. We'll catch our error if we make one over here. Strip diagram. Let's see. So if I do, let me go ahead and make a 5 hour or 5 strips. And then we have, so this is 5 scarves. And I can make that in what, 10 hours. So every strip is worth what, 2 hours? Okay. So then if I want to make 7, I would know that I have my 10 and then 2 more. So then that 14 makes sense because to make this many takes 10 and I'm tacking on 2 more. So 14 hours is sounding better and better. All right. Timeline method or double number line method, work and answer. Okay. So timeline is kind of another name for like a double number line here. All right. So I'm going to do what? 5 hour or 5 scarves in 10 hours. Now, cutting, you can't do 2.5 scarves. So you have to cut 4 cuts to make 5 things. So this will be 1, 2, 3, 4. So if I cut this into 5 pieces, you see how there's 5 gaps in there? I have to divide this by 5. So 2, 4, 6, 8. So then to get 10, I need to get to what? What do I want? To make 7 scarves, so I need to measure twice more. So I'm going to take that distance measure over. 6, 7. This is 12. This is 14. So again, this is where I want to land. So that would be 14 hours. Next one, okay, 4 assembly lines. And okay, I'm going to skip this one for a second. We're going to come back and do that. That is an inverse relationship. And so I want to make sure I have enough time on the video. So I'm going to wait because I only have 3 minutes left. 3/4 of a dentist recommend total. So if I have 3 out of 4, that means this person recommends, this person recommends, this person recommends, this person's like, nope, I do not. Don't like it. So total, if there are 60 dentists at a convention, so I have 60 dentists at a convention, how many would recommend total? So 60 is my total strip. Divide by 4. So what is that? 15, 15, 15, 15. Okay, that should add up to 60. How many would recommend it? So the recommended people would be 45 dentists. And then the other one would be 15 dentists. So these are the people that would, these are the people that would not. All right, typically 4/5 of the students eat hot lunch. You have 125 bring sack lunch. How many students would you expect to eat hot lunch? Okay, so again, I'm going to make a strip and have 5 parts to it. 4 of the parts eat hot lunch. So hot lunch, hot lunch, hot lunch, hot lunch, and then this is a student that brings cold lunch. So if 125 students bring sack lunch, okay, so that's your sack lunch people, the cold lunch people. And it says 125 bring it. So that means this little strip is 125, which means all of the little strips are worth 125. Okay, and so if I want the total in the school, I'd add this. Here it says how many would you expect to eat hot lunch? So I have 125 times 4. So again, it might be easier to do 250 and 250 in your head, which is what, 500 students eat hot lunch. All right, I'm going to pause here and flip the page. We'll see if we can get one more done here. Okay, let's look at this one. If you have a decimal, you just have to move it 2 to the right to convert it to a percent. So this would be over, because 1 is 100%, this is 2, so it's over 100%, it's over 200%. Again, move the decimal twice, this would be 56%. This one is already out of 10, so you could just multiply it by 10 to get it out of 100. So 170 out of 100, that is the definition of percent. Percent is out of 100. That's why here, this is 56 hundredths. If you want to write it as a fraction, this is 235 hundredths. So that's why we can just move the decimal twice. Here, I break it into 4/8, which is 50%. A fourth would be, what, 25%? I have half of that. So this is what, 12.5%? So 62.5. So you either need to memorize that or just kind of be able to do it. 1/3 is 0.3 repeating, so 2/3 is 0.6 repeating, and as a percent would be 66.6 repeating. Here I could scale by 5 and get 35 out of 100, so it's 35%. The other thing you could do is get 3.5 out of 10 and then just multiply by 10 and 10. And this one would be 6 out of 10, which is 60%.